Hi students, now we are going to solve problem number 10 which is based on Kirchhoff's laws. So look at the closed loop. Now here there are three closed loops in this circuit diagram. One is A, B, E, F, A. Other one is B, C, D, E, B. And the third loop is a larger loop, A, B, C, D, E, F, A. Okay, now there are two cells included in the circuit. One is 15 volt, the other one is 9 volt. And there are several resistors, okay, 100 ohm, 100 ohm and 100 ohm. So in different branches, what are all the currents flowing are given in the circuit. So you can see that the 15 volt cell is sending a current of I1 ampere. So this I1 ampere flows up to A. Then the same current I1 has to follow. The same current I1 has to follow, okay, up to B. Now you can see here. Now you can see this point. When I1 ampere is approaching the junction B, it is dividing in two different branches. So the current I1 ampere, after reaching the junction B, it is splitting in two branches as I2 along BC and I3 along BE. So at the junction B, okay, so apply Kirchhoff's current law, Kirchhoff's first law, which is called Kirchhoff's current law at B, okay, at junction B. So current I1 is equal to I2 plus I3. So this is I2 plus I3. So this is the first equation required. Okay, so it is based on Kirchhoff's first law. Now apply Kirchhoff's second law or voltage law, the Kirchhoff's second law or voltage law to the closed loop A, B, E, F, A. So this is A, B, E, F, A. This first loop, which is a smaller loop. Now A to B, there is no resistance, there is no resistor, so there is no IR product. The current I1 is flowing, but there is no resistance. Now in the branch B to E, what is the current flowing is I3, and the resistance in that path is 100. Therefore the IR product is 100 into I3. So I will write like this, 100 I3. Next I am proceeding from E to F, from E to F. So at this junction E, the current I3 ampere and the current I2 ampere will join, and again the net current will be I1 along this path EF. This I2 and I3 are joining and going along the direction EF as 100 ohm. So IR product is 100 I1. So this is plus 100 into I1. Now in this branch F to A, there is no resistance. There is no resistance. Therefore there is no IR product. So this net IR product is 100 I3 plus 100 I1. Then again you come from A to B and B to E, E to F and F to A, and find out how many cells or batteries are there in that loop. What is the net EMF you have to find out. So A to B there is no cell, B to E also there is no cell, E to F there is no cell, and F to A there is one cell of EMF 15 volt. Now which terminal of the cell is sending the current I1? Is it positive or negative? You see here, the current I1 starts from the positive terminal. Therefore this 15 is positive. So this 15 is positive. Is it not? Then again in this equation, from 1, I1 is equal to I2 plus I3. So instead of I3, we can substitute I1 minus I2, is it not? Instead of this I3, I am going to substitute I1 minus I2. So I am rewriting this equation 100 into I1 minus I2, okay, plus 100 I1 plus 100 I1 is equal to 15. So open the bracket, it is 100 into I1, 100 into I1, okay. So this is 100 into I1 minus 100 into I2, okay, plus 100 into I1 is equal to 15. So this I1 and I1, 100 I1 plus 100 I1 will become 200 I1 minus 100 I2, and that is equal to 15. So this is equation 1. So equation 1 is derived by applying Kirchhoff's second law or voltage law to the loop A, B, E, F, A. Have you understood? Similarly, one more loop I am going to consider, that is preferably B, C, D, E, B. Okay. So now KVL applied to the second smaller loop, namely B, C, D, E, B. So this right side loop. Now you start from B to C. There is no resistor, no IR product. Then C to D, there is 100 ohm resistor through which current I2 is flowing. So I will write 100 into I2. Then D to E, there is no resistance, no IR product. Now I am going to proceed from E to B in the upward direction. I am going to proceed from E to B in which direction? Upward direction. But in which direction the current is flowing? You see here I3 ampere of current. Is it flowing from the top to the bottom? So we are proceeding upward. Current is coming downward. So I will write a minus sign for the IR product. What current is flowing is I3. And what resistor is? 100. So this is 100 I3. Okay, 100 I3. And this is now equal to the net EMF in this loop. So what is the net EMF in this loop? There is only one cell here. That cell also is sending a current I2 ampere from the negative of the cell. So from the negative the current is leaving, means this EMF 9 volt. 9 volt must be negative. So this must be equal to minus 9. Okay. Once again, I3 I am going to substitute. I am going to substitute for I3. So what I can substitute here? I3 is equal to I1 minus I2. Okay. So this is 100 I2. Okay. Minus 100 into I1 minus I2 is equal to minus 9. So this is 100 I2 minus 100 I1 minus 100 I1. Minus of minus will become plus 100 I2. So this is plus 100 I2. So this is equal to minus 9. So this 100 I2 plus 100 I2 will become 200. Okay. So this is 200 I2 minus 100 I1 is equal to minus 9. So here this equation here you will see that here 200 I1 minus 100 I2 is there. So if you add, you can eliminate either I1 or I2. If you eliminate either I1 or I2, the other current can be easily found. So 200 I2, here 100 I2 is there. Okay. So we can multiply the first equation by 2, or the other way also. Here you can see here minus 100 I1, here 200 I1 is there. So this equation can be multiplied. This equation can be multiplied by 2. So that this is 400 I2. Okay. Minus 200 I1 is equal to minus 18. So this also can be taken as equation 2. Now look at equation 1 and equation 2. In the second equation, minus 200 I1 is there, and in the first equation plus 200 I1 is there. So if you add equations 1 and 2, this I1 can be eliminated. So adding equations 1 and 2. So when I add this minus 200 I1 and plus 200 I1 get cancelled. So what will be remaining is this 400 I2. Okay, 400 I2 minus 100 I2. So minus 100 I2 on the left hand side. I1 gets eliminated, is it not? Minus 200 and plus 200 I1 get cancelled. So remaining is 400 I2 minus 100 I2 is equal to 15 minus 18. Okay, so this is 15 minus 18. Okay, 400 minus 300. 400 minus 100 is 300. Okay, I2. 300 I2 is equal to minus 3. Therefore, what is I2 is equal to minus 3 divided by 300. So this is equal to minus 1 by 100. Minus 1 by 100. So minus 1 by 100 is therefore I2 is equal to minus of 0. So 1 divided by 100 means 2 decimals will come, is it not? Okay. So this is a 0.01 ampere. So 0.01 ampere with a negative sign. So I2 is equal to minus 0.01 ampere. Now in any of these earlier equations, in any one of the earlier equations, you can take either 1 or even before that, okay, or any equation. If you substitute for I2 equal to 0.01, the current I1 can be calculated. So I am going to consider the simplest equation. This equation I am going to consider, okay, this equation. In any of the earlier equations involving I1 and I2, okay, so I am going to substitute I2 value here. So 200 into I2, 200 into I2. So 200 into minus 1 by 100 ampere, okay, minus of 100 I1, minus of 100 I1 is equal to minus 9. In this equation I have substituted I2 is equal to minus 1 by 100. Minus 1 by 100 means easy for cancelling, is it not? So 100 and 2 zeros get cancelled. So this is a minus 2 minus 100 I1 is equal to minus 9. So that minus, if I will take out, means 2 plus 100 I1 is equal to 9. Okay. So this 100 I1 is equal to 9 minus 2. So 9 minus 2, that is equal to 7. Therefore I1 is equal to 7 by 100. 7 by 100 is equal to 0.07 ampere. 0.07 ampere. So I1 also we have determined 0.07 ampere. Already we have determined I2. Now we have determined I1 also. So Kirchhoff's first law, first equation is I1 is equal to I2 plus I3, or I3 is equal to I1 minus I2. Using that, I3 also can be determined. Therefore, okay, therefore I3 is now equal to I1 minus I2. From equation 1, I3 is equal to I1 minus I2. So this is now I3 is equal to I1 is 0.07 or else 7 by 100. Okay, I will write like this, 7 by 100 minus I2 is already minus 1 by 100, is it not? So this will become what? Minus 1 by 100 in bracket. So this is equal to 7 by 100 plus 1 by 100 is 8 by 100. So this is equal to 8 divided by 100. Okay, so this is 0.08. Therefore I3 is now equal to 0.08 ampere. So we have determined I1 equal to 0.07 ampere, I2 equal to 0.01 ampere, and I3 equal to 0.08 ampere. Okay students, I hope you have understood.